Hello everyone, my name is Eduardo. Welcome to this webinar where we will explore the latest tool in evolution. Since Maptek acquired the evolution from Origin in 2014, we made great progress on further development the scheduling bandwidth. Product development takes advantage of the Maptek's 35-year experience in mining and our shared platform, especially through the Workbench Foundation and our visualization capability. The software was branded as Evolution in early 2015 and is now available as Evolution Strategy and Evolution Origin and now Evolution Phase. Maptek is currently developing Epoch, which is the short-term scheduling solution using the evolution architecture and optimization engine. This is due for release in first quarter of 2017 and will be suitable for both stratigraphic and metalliferous operations. Spreadsheets, a linear approach that cannot handle the scale and flexibility required by modern projects. Evolution can. This has been confirmed for a number of new customers who have been adopting our solution. Some of the evolution benefits include increasing value by increasing grade early in the schedule, advanced constraint modeling, blend optimization constraints, interoperability with Vulkan, integrated haulage and waste landform scheduling, easy to set up and quick to run, reliable and repeatable outcome. Maptek Mine Scheduling Solution expert Steve Craig will today demonstrate how Maptek Evolution Phase and Strategy can be used to improve the project value. If you have any question, please enter them in the question panel at any time during the webinar. The recording will be available in a day or so, and everyone will receive the link to access and share with colleagues if you wish. Please welcome Steve.
Thanks, Eduardo. As discussed, we're going to focus on the ideas of cutoff grade optimization and phase design and the impact that this approach will have on value generation. We often see and hear the issues associated with stage design and scheduling where we need to simplify the optimization results prior to scheduling. In this example, I have two views outlining the results from a complex pit optimization run. In this state, it would be quite difficult to get a practical high-value schedule from this data. Hence, there is some simplification required prior to scheduling, and this is normally done through some detailed phase design. However, as a rule, we are generally time poor, and there is little in the way of quickly transferring outcomes from pit optimization into the area of stage or phase design. It is relatively easy to get an ultimate pit shell and corresponding ultimate pit. But what happens between now and this endpoint is a function of shell selection, experience, and gut feel. Hence, engineers rarely get more than one bite of the cherry when it comes to stage design. I can't emphasize enough that one of the most important aspects of scheduling is the quality of the stage designs. Good stage designs are the holy grail of scheduling, and there is a saying that schedules are really only as good as the stage designs on which they are derived. Good quality stage designs are the focus of evolution phase. This process is now incorporated into the evolution workflow in a seamless and auditable manner. Phase allows the engineer to take outcomes from a pit optimization run and use this as a mechanism to make valued phase designs based on accumulating or manipulating blocks in 3 dimensions. The outcome of this is to provide very quickly inputs to a scheduler which can pre-qualify whether designs will work from a scheduling perspective. And what I mean by that is, will all tonnages be reached? Will there be no peaks in waste stripping? And is value still being maximized? The engineer can now rapidly iterate between phase and strategy to ensure that the schedule works before moving on to the effort of actually designing the stages. Together with evolution strategy, the engineer now has incredible power to add value by generating practical, high-value stages with the added benefits of using advanced cutoff grade optimization techniques. In some cases, we've seen in excess of 20% of value being added by using these two techniques. Prior to talking about phase and strategy, I want to revisit two concepts. Firstly, what is meant by a cutoff grade, and what does that actually mean? And secondly, what is a grade tonnage curve? Firstly, a cutoff grade is simply a division between what is ore and waste, or what makes money and what doesn't. It's a very simple formula that describes how much metal is required to cover the cost of processing. The following formula has many derivatives and can change significantly from company to company depending on what they want on the cost element, but in the end, this is pretty much the most simple derivative of this formula. That is, processing costs divided by processing recovery multiplied by price. In this table, I've tabulated cutoffs for both a leaching and a milling operation. In their own right, if there was only a leach operation, then the gold grade, where it's greater than 0.38 grams per tonne, the ore would be leached. If there is only a milling operation, then ore above 0.48 grams per tonne would be processed. However, if we have both processes, then ore above 0.69 grams per tonne would make more money being processed in the mill, and ore between 0.38 and 0.69 would make more money being processed in the leach process. This 0.69 gram per tonne cut is called a cutover grade. Secondly, a grade tonnage curve is a collection of cumulative tonnes and grades at a range of predefined grade bins as shown. They offer a lot of insight to the engineer and can help shape a project in its most appropriate direction. In this case, we have a project that is relatively low grade, where we have around 44 to 45 million tonnes at 1.1 gram per tonne. However, if we interrogate the curve in some more detail, we can actually see that there is a high-grade component of around 8 million tonnes at about 3.2 grams per tonne. So evolution will use this information on a bench-by-bench basis and will mine this grade tonnage curve proportionally during the course of scheduling. Now, let's get on with looking at phase and strategy. We're going to look at a range of options. Firstly, we're going to look at a fixed cutoff grade policy. We're then going to look at what we actually mean by optimizing the cutoff grade. Thirdly, we're going to add and look at the impact of what the stockpiles have to the process. And then what happens if we do add another process? Can we actually improve value? And lastly, I would like to introduce evolution phase and how it can be used to rearrange phases with the idea of adding value. So if I just go to evolution, this is the evolution interface where we have the ability to look at our block models in 3 dimensions, the ability to run setups, and also to review results. If we start off with our block model, we have the ability to, in this case, show our 2 stages. So I have stage 8 and stage 9. And I also can look at how the gold is distributed, which in this case you can see that it's reasonably well distributed throughout the model. And finally, I can actually have a look at how the value is distributed as well. In this case, purple is waste, and anything that is not purple is potentially ore. Now, when we would like to look at a setup associated with strategy, the easiest way that I explain to people what is strategy, it's effectively a workflow that allows an engineer to work through in a structured manner the ability to develop a cutoff grade policy. So in this case, we have our model, which is our source, and our destinations, which is material will effectively be going through a crusher and onto the leach pad. Secondly, we define the items that we would like to use, and in this case I'm using total tonnes in our model. I'm using our ore tonnage item for our ore tonnes, and then the gold grade to actually show what the gold grade is looking like in a vertical slice through the ore body. Thirdly, I would like to show and work out what I would like to process on a lithological basis. So in this case, I'm looking at 3 different lithologies that I'm going to be working with. With tab number 4, we can define our grade bins, and this is effectively building our grade tonnage curve. I'm starting at a grade of 0.2 grams per tonne and increasing in increments of 0.05. So we can see each of the incremental tonnes and grades for each bin, as well as the cumulative tonnes and average grade overall. We can look at that as a tabular form, or we can actually look at it as a grade tonnage curve. And finally, we can actually look at how the lithology is being split on a stage-by-stage basis. The main components of strategy reside in our economic model and how we build this up. In this case, our main ideas is that we want to look at our capacity constraints for our mining, whether we would like to add in capital and also our fixed costs, as well as what we would like to be doing in terms of our leaching capacity as well as what we can crush. At any given point in time and by period, we can define our price as well as our selling cost. When we want to configure how we would like to set this up, our global cutoff is sitting at 0.38, and if I come back to a couple of slides, this is our 0.38 grams per tonne, which is focusing on a $10 price and a 65% recovery for our processing. If we have a look at our variable costs, we can actually build a complex geometallurgical model inside Evolution and then use this as a mechanism to interrogate from an optimization perspective. So here we have our leaching costs and our leaching recoveries at a block-by-block level, together with our mining costs. We can also inject capital dynamically depending on when a particular stage is being mined as well. Now, in this case, I'm running a fixed cutoff grade policy, so I'm forcing strategy to work at a fixed cutoff of 0.38 grams per tonne. What we also have the ability to do is add multiple constraints, and for example, we have a range of different constraints that we can add to help with developing practical high-value high-value schedules. But let's just, before we go into that, let's have a look at the results from this cutoff grade optimization exercise. And so you can see here that we've run a cutoff grade at a fixed cutoff, and this schedule is generating an overall MPV of just over $400 million. And you can see that if we look at the charts, that we can see our total material moved, our waste tonnages, and our ore targets being met. And here is our cutoff grade policy that has been defined at 0.38 grams per tonne. We can also show at a Gantt style a view of what is being mined, and then also our bench turnover. All of this is a standard report. It's not scripted. It's just available to the user at any given point. As part of this, we actually give a lot of detail to the user where we actually show how much is being mined on a period-by-period basis that's coming directly from the pit, as well as whatever material is being reclaimed. And we also show the financial aspects of that on a period-by-period basis. Now, let's just close that one down and close that. Now let's open up our variable cutoff grade setup. You can see that it's no different. The only thing that we're doing here is allowing the optimizer to float our cutoff grade depending on whether or not we are hitting either a mining capacity constraint, a leaching capacity constraint, or a refining or market-orientated constraint. So on a period-by-period basis, we will be going through and balancing those cutoff grades to maximize the value now. If we have a look at the results associated with that, is that we've now gone close to about $450 million in value. And one of the main outcomes of this is that we now see that our cutoff grade on a period-by-period basis is fluctuating. And if I look at our cutoff grade curve now, you can see that we're now, over time, we're now increasing because what we've done is we've exposed a lot of ore to the optimizer, which now has the ability to choose which ore it can use to increase value. Now, in this particular case, anything below the green line is effectively waste, and then anything above the green line will be leached. So if we come back to our numbers, we can see that we started off with 44 million tonnes. We now have 35. So we've effectively reduced mine life and lost about 9 million tonnes of material. Not a very good career limiting move when you say to your mine manager that we've lost 9 million tonnes. So our next port of call is to then add some stockpiles. Now when we add stockpiles, the first thing we're going to be required to do is to look at the cost associated with rehandling that material, and secondly, the size of our stockpile as well. So in this case, we're allowing stockpiles to be used, but I'm limiting their capacity to 20 million tonnes. And when we do that, the results from that are, we've now got our 44 million tonnes back, and you will find that we still have a cutoff grade policy that's floating. So if I look at that in some detail, you can see our cutoff grade is now floating, and you can see material being stockpiled and then reclaimed at the end of the mine life automatically. Now, we can now say to our mine manager, it's okay, we've got our 9 million tonnes back, but what we're doing is we're saying that on a period-by-period basis, anything below this blue line is being wasted. So I see a 0.38 gram per tonne. Anything above 0.38 and this green line will be stockpiled, and anything above the green line will be processed. And again, we have the ability to show all of that information by bench turnover, as well as what stages are active at any given point in time. Now, when we do that, you can see that by adding stockpiles, we've added a little bit of value. We've added around, I think, around $4 million in value. So not a lot, but we continue to still incrementally add value. So, when we looked at our grade tonnage curve, we highlighted the fact that there were a high-grade component in there that I would like to test whether or not I can add value by adding a small milling circuit. So when we look at that type of setup, it's simply evolution allows us now to add multiple processing and multiple processes, as well as we can also add multiple models as well. So in this case, what I'm doing is I'm allowing the optimizer to allow the ore to compete, whether or not it's going to make more money going into the mill or more money going through the leach circuit. If I have a look at the results associated with that, I can now see that I've got my 40-odd million tonnes that I'm still working with, but I've now generated some more value here. I've also allowed for the capital associated with building that milling circuit as well. So I'm still incrementally adding value, and so I'm still getting a feel for that this may be a viable opportunity. So if I look at my charts, I can now see a breakdown of what is being leached and what is being milled, and also what is going to each of the residual stockpiles. Now, what I mean by that is I can now see that below this orange line, material will be wasted. Between the orange and yellow, that material will be leached. Between the yellow and the blue, that material will be stockpiled for the milling circuit. And above the blue line, that material will be milled. So we now have a variable cutoff grade policy for each of those processes. Now, the next thing I wanted to do is to bring in evolution phase, because my main goal now is to look at taking these two stages. So if I go back a few steps, I've already prepared this for the sake of the demo. We have our two stages. Now with evolution phase, we have a series of rules and tools associated with where we can merge things together. We can apply some mining orientated or minimum width type mining rules, as well as a range of other rules which allows us to combine things, split things, and actually do very detailed block editing as well. Now in this case I've just got a number of very quick and simple examples of what evolution phase can do, and what we can do is we can replay them. So effectively when I look at this stage, I can see that there are some natural breakpoints that I might start thinking about. So firstly, I want to split these particular, this stage into two separate stages, and then secondly into a third stage over here. Now, what I can also do is I can look at I've noticed that when I look at the value aspect of this, I can see that there is some value here that I can get access to without having to start at the very top and mine my way down. So what I'm going to do is add another stage. If I come back to my view manager, take that off. And now what I would like to do is I've added another stage, and now what I can then do is actually look at that area in some detail and look at effectively high grading. Now when I come back to my project manager, if I look at my new setup, which is the last one, but now I'm adding in, instead of 2 stages, I'm now adding 5 stages. Effectively all I have done is I have told evolution to now use this new phase ID compared to the old phase ID. So it's a very simple and straightforward operation to allow evolution to look at new stages. Everything else is exactly the same as what we had done before. So if I was to look at the latest results that I ran, I can now see that I'm now getting close to, or in excess of $480 million. So if I was to look at this in some detail, okay, I can see that with the first 4 options, I've added around 10% in value by looking at each of those incremental operations. As a mining engineer, I look at value in two areas. One being the overall net present value, allowing for the cost of time. But secondly, I also look at the actual cash flow that I have available on a period-by-period basis. And in particular, I'm actually graphing the cumulative cash flow between each of those options. Now, with that last operation, we've been able to add, allowing for capital, another $20-odd million, which has actually increased our MPV to around 16% in extra value compared to running a fixed cutoff grade. Now, the idea of cutoff grade optimization has, in my eyes, is one of the single most value-adding concepts that a mining engineer can do to their operation. So, in summary, the combination of phase and strategy, we've proven that we can add significant value to a project, and we do this time and time again. More to the point, whilst value is an important factor, as I said, the early cash flow can be considered extremely important to developers, bankers, and shareholders. Hence, the ability to defer expensive stripping into the future without compromising the integrity of the overall operation, whilst also being able to examine numerous scenarios very efficiently, is of critical importance to the mine's future development. So that's enough from me. Eduardo, have there been any questions from our participants?
Thanks, Steve. It was great to see how evolution development continues to add value to operation through dynamic and flexible scheduling functionality. Yeah, we have some great questions coming in. If we run out of the time to answer them all during the webinar, we will be in touch with you directly. Let me take a look to one of those. Steve, how long did it take you to work out this scheduling example?
Okay, if we come back to if I go online and we have a look at how long those jobs took to run, our evolution strategy also works online in a cloud environment. And if I was to look at, say, for example, that last job that I ran, we started at 2:21 and it finished at 2:23. So we're taking around 1 to 2 minutes to actually run through a schedule. So it allows, as that shows, it's very quickly and easily allows the engineer to test lots of scenarios very efficiently.
There is one question which is, I really like the graphing. How could you use in report? Is it easy to export the report?
Sure. So if I come to here, any of these reports and any of these graphs can simply be copied and pasted into either a spreadsheet or really anything else that you require, and then used in any other way. So anything to do with the numbers that we generate, as well as our charts, can all be exported to different formats and other applications.
Excellent. Another question here is, how does evolution strategy optimize?
Oh, okay, great question. If I come back to that area that I was in just before, here we actually, as we work through the actual optimization process, we actually run simultaneously numerous schedules at the same time. Now, some of those schedules will have a high cash flow, some of them will have a low cash flow. And during each particular generation that we run, our goal is to try and improve and focus on improving the value. So within our population of schedules that we're looking at, there'll be some of those schedules will always be improving as we go through generational time, and then there'll be a bunch of other schedules that are also improving and playing catch up. And you can see that what we're doing as we're going through and incrementally changing the sequence, and then when you see these jumps here, what we're doing is we're actually now, we've fixed a sequence, and now we're playing around with the cutoff grades. And you can see that there's been an improvement in the value. But what this means now is that all of the other schedules are now trying to play catch up. And you can see that as the difference between our worst case and best case cash flow starts to get smaller and smaller and smaller, we actually get to a particular point where there's very little value add, and at that particular point we then turn the optimizer off.
All right, thanks, Steve. The next one is, is evolution phase included in the evolution package?
Two answers to that question. You can have evolution phase as a standalone package, and what you will see is effectively the ability to look at block models and phases together with the analysis. You won't see utilities, equipment, strategy, or origin. So it can be used as a standalone package, and the second answer to that question is that you can bundle phase together with strategy or strategy and origin so that you can have a complete scheduling package.
Perfect. This is the last question that we got at the moment. Can we use solid in desktop block models?
Okay. Now, at the moment, evolution, origin, and strategy work with three-dimensional regular block models, as we see here. Where we're moving for our new product, which is due for release in Q1 2017, and that product is called Evolution Epoch. That will effectively be replacing the three-dimensional block model with a series of attributed solids. and that information will be then the source information that the scheduler will use. Now we see a lot of value in that approach, where we can actually work with stratigraphic orientated mines as well as metalliferous mines in a short-term planning environment, for example. And that will use solids from, at the moment we'll be reading in information from Vulcan, attributed information from Vulcan.
Excellent, Steve. Thank you for providing an overview of the latest Evolution OpenPit scheduling tools. Maptek is excited because we will be able to provide to the user a single solution that can manage all the scheduling horizon, taking advantage of the modern optimization techniques. As a side issue, and as touched in the question, be on the lookout for announcement early in the new year with what is happening with Evolution Epoch. We will be taking our sophisticated optimization engine logic into the short-term planning environment to ensure we can comply with long-term plans whilst ensuring short-term plans are not being compromised. Colleagues who didn't register can also watch the webinar, which will be live early next week on maptek.com. From this page, you can also access recording of all the recent Maptek webinars. Thank you again, Steve. Don't forget you can contact your local Maptek office for further information about content in today's webinar. Thank you for listening, and bye for now.